Welcome to the Minuteman Power Technologies Power Learning Series. In this installment, we will be looking at the three types of uninterruptible power supplies, or UPSs, and how they function. All three types provide full protection from any power anomalies. The differences lie in how that protection is executed. Let's get started. A standby UPS is the most basic type. Here's how it works. Utility power comes into the UPS and flows through in normal mode while also charging the battery. Minuteman's Inspire series employs standby UPS technology, switching to battery backup whenever power issues occur. There are 4 models in this line with capacities ranging from 350 to 900 VA. You see 3 measurement devices we have set up. The first one is a voltmeter showing the input voltage provided by utility power, currently reading at 120 volts. The second voltmeter shows what voltage the UPS is providing as an output. The third device is an oscilloscope that shows the type of waveform the UPS is sending to the attached equipment. When the input voltage drops below a certain threshold, as it shows 89.6 input volts, the UPS switches to battery mode and provides a stable 120 volt output. As you see, the output waveform is now a simulated sine wave and provides backup power to the attached devices. As the input voltage increases back into a normal range, the UPS passes through normal AC power. As voltage increases, the UPS will sense that a dangerous voltage level is nearing and will switch to battery mode to protect the attached devices. As you see, it switched over at 147 volts and is now providing battery backup power. Again, the UPS is providing a simulated sine wave output. As you see from the LED display, AC power is normal and the green LED is illuminated. When power conditions exceed the acceptable range, the UPS switches to battery mode and the yellow LED is displayed. Once again, the block diagram shows battery mode operation. The next type of UPS we are examining utilizes LineInteractive or automatic voltage regulation technology to solve undervoltage conditions. Utility power comes into the UPS and flows through in normal mode, while also charging the battery. In Minuteman's Entrust LCD series, there are 4 models with capacities ranging from 550 VA to 1500 VA, and these models are a step up from the standby UPSs because of the integration of voltage regulation technology. You see our input level on the left voltmeter is showing 120 volts, and the output voltmeter is showing 120 as well, while the oscilloscope is showing a sine wave output. As we take the input voltage down, at 104 volts, the UPS goes into boost mode, providing a safe output voltage. As the input voltage drops further down, the UPS is still providing a stable output voltage. As you see, at 85 volts, the UPS switches to battery backup mode, providing a simulated sine wave output. The block diagram shows the power from the battery is providing stable voltage to the attached devices. As you see on the LCD screen, the UPS provides 45 minutes of backup time. As we increase the voltage, the UPS switches to boost mode. As we further increase the voltage, the UPS switches back to normal mode. If we continue to increase the voltage, the UPS will switch to battery backup mode to protect from high voltage damage to the attached equipment. Even though the input voltage is 142, the UPS is still providing a stable output voltage. The next UPS family we will examine is Minuteman's Pro RT 2U series. These UPSs are rack mountable with the option of upright floor mounting as well. These models are LineInteractive and range from 750 VA to 2000 VA. You see the input voltage is normal, as is the output voltage. As the input voltage decreases, we see the UPS switching over to boost mode at 102 volts, while the output is a stable 123 volts and supplying a sine wave output. If we continue decreasing the input voltage, the UPS switches over to battery mode at 85 volts. The block diagram shows the UPS is operating in battery mode. The UPS is providing a simulated sine wave output. The LCD display shows 92 minutes of estimated runtime for the connected load. As we go back up in voltage, the UPS will switch to LineInteractive mode. You'll notice that the output is now back to a true sine wave. The diagram shows it's in boost mode now. As we further increase the voltage, we return to normal operation mode. As we continue to increase the input voltage, we see that the UPS goes into buck mode, reducing the input voltage from 132 volts down to a more usable 112 volts. The block diagram shows buck mode is now enabled. When we reach 152 volts, the UPS switches to battery mode to protect the attached load, providing a more stable output voltage. The waveform in battery mode is a simulated sine wave, and the LCD display shows 92 minutes of estimated runtime. In bringing the input voltage back down, buck mode kicks in to regulate the output voltage. The next line of UPSs is the Minuteman Enterprise Plus series, which is a LineInteractive UPS ranging from 750 VA to 3000 VA in capacity. This product line differs from the previous models in that it provides a true sine wave output in battery mode versus a simulated sine wave output we found in earlier products we've discussed. These models also provide a wider range of voltage regulation, featuring double boost and double buck modes. As you see, the input and output are operating normally. As we decrease the input voltage, we get the first boost mode at 102 volts while maintaining a 120 volt output. At 87 volts, we hit boost mode 2, but the output is still around 120 volts. As we further decrease the voltage, the UPS will switch to battery mode at around 77 volts, but the output, as you see, is 120 volts. Note that we are in battery mode now, but the UPS is supplying a true sine wave output. The LCD display shows 407 minutes of estimated battery backup time, and as you see, the block diagram shows that we are in battery mode. As we raise the input voltage, the UPS will switch to LineInteractive mode until we reach normal voltage. As we increase the input voltage to 132 volts, we see the UPS going into buck mode, providing a stable voltage output. As we are increasing the voltage more, we hit 148 volts and a second buck mode is engaged. Note that the UPS is still providing a normal level of voltage. As we further increase voltage, the UPS switches to battery backup mode at around 166 volts, while the output is a continuous 120 volts. Once again, note that the output waveform is a true sine wave, and the LCD display shows how much runtime will be provided to the attached devices. Looking at the LCD display more closely, you'll notice various operational modes. As we decrease the voltage, you can see the display shows the decrease. In the upper left-hand corner, the LCD is showing that it's switched to boost mode. As voltage further decreases, the UPS switches to battery mode, and the LCD shows the battery icon and the estimated runtime. As we increase the voltage back up to 112 volts, the UPS returns to normal mode. We now will look at a true online UPS, which is Minuteman's Endeavor series. The block diagram shows that an online UPS is more complex. An online UPS converts incoming AC power to DC power, and then at the output, it converts the DC power back into AC. This is called the double conversion process, and it's utilized in an online UPS. This technology provides the best type of UPS protection available. As you can see, the input voltage is 121 volts and the output is 120 volts. The output is also a true sine wave at all times. As we decrease input voltage, note that the output voltage stays at a constant 120 volts. Note that there is no switching because the inverter is online and regulates the voltage in real time. The block diagram shows the UPS is producing a stable output voltage even with a low voltage condition or no voltage at all. This is illustrated when we decrease the input voltage down to 52 volts, while the UPS is still producing 120 volts at the output. The UPS maintains a true sine wave output at all times. The LCD display shows the estimated runtime for the load. As we increase the voltage, there is still a constant 120 volt output. The input load, as you see, is 158 volts, while the output is still a stable 120 volts and a true sine wave. Decreasing the input voltage back to the normal range shows the output continuously stays at 120 volts with a true sine wave output. Thank you for viewing this video on the 3 types of UPS technologies Minuteman offers. Minuteman has been providing reliable power protection solutions since 1982. Our full line of products are available from resellers and distributors across North and South America. Please visit MinutemanUPS.com for more information, or call us at 972-446-7363.